A lot of folks are intimidated by physics. What's more intimidating, though, is when you dig deeper into what might be called a subspecies of physics. For example, what is fluid dynamics? And who works as a fluid dynamicist? Fluid denominator? Dynamicist. Anyway, Jaime Duquette was trained to do precisely that. Hi, come on in.
Hey, Peter. How are you?
Is it a big deal for you to leave the campus? Or...
I am working home today.
Oh, you are?
I just said I have a thing to do at noon. I checked my email before I came in, and they don't even miss me.
It occurred to me as a writer here at the Day that over and over again, you see people attempting to describe someone or something that's particularly intelligent or brilliant or whatever, and they will say it's not rocket science, or I'm not a brain surgeon, or there's the always the go-to, I'm not Einstein. It's as though he was the only smart person that ever existed. But so I didn't want to fall into the trap of using those stereotypes, and I thought, what is out there that would be similar but different and fresh on the ears of those of us who are laypersons? And so I flipped through an MIT course catalog, and I came across a discipline called fluid dynamics. And I thought, that sounds arcane as hell. And I ran into my friend Jaime Duquette, who is our guest today. Hi, Jaime.
Hi, Rick. How you doing?
Thanks for being here.
Glad to be here.
And I knew that Jaime is a mechanical engineer, correct?
Yes.
So the next time I saw Jaime, or when I ran into him, I said, hey, what's up with this fluid dynamics thing? Have you ever heard of that? And you said...
As a matter of fact, I am a fluid dynamicist. I went to school for that. That's what was my main course of studies.
You know, that wasn't what I was expecting. I didn't expect you to say, I am a fluid dynamicist. But you were.
Yes.
And it was like winning a lottery sort of thing.
Was it?
For me, it was, because I thought, well, he's an engineer. He'll say, yeah, I've at least heard of it.
Yeah.
But no, you are.
It's what I studied.
That's what you studied.
That's not what I do now.
And we're going to get to what you do now.
We'll get there.
I'm fascinated by what do you do? What is a fluid dynamicist?
It's the study of fluids.
By God, I knew.
Wow. Any kind. It's water, air, water and air, basically, or plasma, whatever. Through a medium, over an airfoil, a wing, like the picture on the book shows.
Jamie's showing me a book
because visuals are really great for radio. It's airflow over a house. Okay. And it shows the airflow over the house and these pockets of turbulence, and so that's how I break it down.
So you're actually showing me a book called A First Course in Fluid Dynamics.
I don't think I could pass this course at this point.
You don't?
I don't think I could.
Because you haven't done it in a long time.
Yeah, I mean, look at the pages are yellow, so that's been a long time since that book's been open.
So if someone came to me and said, let's do some fluid dynamics this weekend, what would be an around the home example of fluid dynamics in my house? In-house, so it's a phenomenon, and you can see it if you turn the faucet on, and water's flowing out of the spigot, right? And it hits a flat surface. It spreads out, in all directions, but a certain area right around where the water touches the surface, it's flat. And then there's a point that there's a bump up. There's like a ridge. So it's like a crater. Yep.
You can calculate that crater, the height of that crater.
I can.
And it's called the Froude number. And that's the one thing I remember from college 30 years ago, the Froude number.
Okay.
And I don't think it was that hard. I think it was like an easy equation, the velocity of the water, distance.
All right.
And another thing you could do is water flow through a straw, a tube. It's a simple.
We have a straw here in my Diet Coke.
I would need I should have brought experiments.
Well, it is radio, as or
right.
podcast.
You go, wow, that's really cool. Pressure head. You have water here and a vessel here, a cup. You can, if the water level is at a height, it will move naturally to the lower level to where it's equal.
Okay.
Pressure head.
Okay. Yeah. Pressure head, Froude.
Pressure head, Froude.
All right.
And some of the stuff I'm making up.
What?
No, I'm explaining it as I understand it.
Okay. That sounds all right. So good.
So if there are any listeners out there say, "No, this guy's an idiot," that's fine too. That's fine.
That's not going to happen. But so at another point, it was your worst nightmare when I discovered that you were this really smart person, because then I wrote a column some years ago in which I was irritated by people just saying you can't put the toothpaste back in the tube, which is a variation of the genie's out of the bottle.
Genie's out of the bottle, yeah.
Now, I don't know any mystics who can explain to me how to put the genie back in the bottle, but I do know Jaime Duquette. So I said, can we, in fact, put the toothpaste back in the tube? And you said?
Yes.
And how do we do that?
I thought about this process because I thought about this problem for this because I remember it. You squeeze toothpaste out of a tube. There's no air in it at the point it's flat, you would hope. As long as you exert a force on the toothpaste equal to what you squeeze the tube at, you can get it back in. But you would need another vessel. Basically, you're transferring from toothpaste tube to toothpaste tube.
Okay.
Or a pump or something. Why would anyone want to do that?
Well, that's a
that's
great
why
point.
That's why the saying is there, right?
Yeah, I suppose so. And I really hadn't thought why anybody would want to do it, because I'm a big fan of toothpaste beyond just the concept of oral hygiene, because I really like close-up cinnamon and mint toothpaste, which are almost impossible to find.
That was a favorite of mine too. Like where can you get it?
I don't know. I suppose we could check on Amazon at some point. But
listeners, call in.
So listen, let me ask you this. What do you do as a mechanical engineer?
I'll avoid specifics.
Right. Can we say where you work?
I will say that I work at Electric Boat.
Okay.
What I do now is I am a general mechanical engineer, and I'm a lead for a very, very large component, and I make sure little boxes fit into the big box. And it's all aspects. It's parts, it's material, I do some wiring now too. I do electrical stuff.
And in your education, you went to Worcester Polytech.
Yes.
At what point did you say, you know what I want to do? I want to be a mechanical engineer. Were you young?
Yes. I think I was in junior high. It might have been, let me think. Yeah, it was junior high. And I just got into, I was really into aviation at the time. And then I want to design airplanes. The other way is, I'm going to go in the Air Force. I want to fly planes. Well, I'm going to design airplanes.
Were you good at math?
No.
Really?
No.
So this is
terrible.
Really? So
terrible
can
math.
one work hard enough at one's craft to become good enough at math to do what let's hope so, because
yes.
you're doing it.
Yes. Yeah, because
yeah, you're over there.
Like early algebra was a challenge.
Yeah.
And then when I got into like high school geometry and calculus, pre-calc, that stuff, that's when it kind of clicked and stuff started making sense.
Do you think you were more self-aware of a lot of? I'm just trying to think back when I was in the 8th grade. I just think it's sort of very self-aware that you would say, in the 8th grade, I'm going to be a mechanical engineer.
And also the household is, my dad was an engineer.
Oh, okay.
My brother was getting ready to go to college at Worcester Polytech. All three of us went to Worcester Polytech.
All right.
So it was kind of the only
That's what you knew.
career that made sense.
Okay.
You know, like people have other careers, and I don't understand how that career works. Bankers, like,
Right.
I don't know. This is concrete. I know I can do it.
Yeah. Do you like it?
Yes, I do. I do. It's surprisingly, some days not so much.
Yeah.
It's a lot of paperwork, but there are a lot of times, and that's when I got into it, I started in Virginia. In my first engineering job was 1997. I started, and it was just a lot of paperwork, and nothing really seemed to be going anywhere. I'm like, what am I doing? This is, but you gain more knowledge, and now I actually do a lot of math when I didn't for many, many years.
Can you say in the context of your job now that like every day is a challenge, or are you doing essentially the same thing over and over again, or is there new math every day? Or?
It's a lot of the same thing over and over, but there are minute changes, you know. So there are some interesting challenges generally throughout a year, let's say.
Okay.
There's installations we do in Newport. Like I've been in Newport since early January, doing an upgrade on a system, and that's a lot of fun. It's hands-on. The customer's right there. We're the two of us that go there. There's an engineer and I work with a technician, and we're well known up there. They leave us alone. They let us do our thing. They trust us. Then I come back here and, there's an issue. This doesn't fit in the spot. I've got to pull out my pencil and let's do some math, make it fit. That's my motto, make it fit. Well, I will make it fit.
All right, cool. Now you mentioned despite your household situation, being surrounded by engineering people, maybe flying airplanes or what, aerospace engineering, astrophysics, is that something else you pursued or studied? Or
aerospace is a path of fluid dynamics. That's like a practical use of it, practical use. When you get into aerospace, you do many things. You do airfoil design. You got to get into materials. You got to get into like CAD design, finite element analysis. And there was one course, and this is the other book I brought, Aeronautical and Aerospace Engineering. This was my favorite course, I think. It was space flight dynamics.
What is it?
Space flight dynamics.
Space flight.
And this is astrophysics, basically.
I'd like to point out, if I may interrupt you, that as someone who isn't entirely comfortable flying, I find that book to be not near long enough. You know what I mean? Like, shouldn't there be more to it than that if I'm going to be a mile high up in the air or whatever?
I'll just orientation angles. It's all Greek. It's all Greek letters.
It is all Greek. Can you speak Greek?
No.
But you had to learn this.
I just said the weird looking D.
I am looking at a diagram in Jamie's book that is the classical Euler angles.
I don't even know what that is.
See, I'm not getting on a plane with you. Okay, but you did pursue that. That's something you knew.
It was one course. It was really difficult because it is very, very. It's math heavy. But I think about it now. That's why I have this book out, because I want to go through it again, and see if I can do some of the math, because of it talks about relationships of two bodies moving in space and how they move in relation to one another. So the moon around the Earth around the sun around the center of the galaxy. That stuff interests me right now. That's like a hobby.
So
just to kind of think about that stuff.
I think that is cool, because as a writer, I often revisit novels that mean a lot to me. And here we have a guy who is revisiting his astrophysics textbook. And I think that's pretty cool.
Mm-hmm.
So let me ask you this. As I was looking through the Worcester Polytechnic Institute Mechanical Engineering course curriculum.
Again, I'm sorry.
No, I think this is fascinating. I'm going to read the name of 4 courses.
Okay.
Now, it's been a while since you were there, but I just want you to know that these course names entertained me and frightened me a little bit.
These were specifically chosen because they frightened you.
Well, I just thought, what in the hell is that?
Oh, okay.
You know, some of them I can understand, at least what they were, you know, but this, so I want you to tell me if any of the 4 of these are something you either took or perhaps you did take and found them hard.
Mm-hmm.
We have, and I hope I pronounced this correctly, kinematics of mechanisms. Did you take that one?
No, I avoided that one like the plague.
Radiation heat transfer application and design.
So that one is a offshoot. That is, I took a course called heat transfer, which is also part of fluid dynamics.
Again.
That is one mode of heat transfer, radiation, and I'm actually surprised that they're going to have a course specifically on that. And I suspect that's for spaceflight stuff. I did I studied radiation and with heat transfer, yes. Wouldn't want to take a full course on it.
All right. Tissue engineering.
Definitely not.
Now, what is that?
Tissue engineering.
What does it sound like?
Yes. It's for biomechanics, they do engineering, they do body engineering, the properties of muscle.
Okay.
My brother, when he was going for his, sorry Jeff if I get this wrong, his master's degree, I think he did like a bone density study. And he dealt with cadavers and hands and yeah.
Okay.
So that is exactly what it sounds like.
All right.
No, thank you.
The last one I wanted to throw at you was control of nonlinear dynamical systems.
I don't even know what that is.
All right.
Linear control. Oh, say that again. I'm sorry.
Control of nonlinear dynamical systems. Is that the right way to say dynamical?
Yeah. Yeah, I don't even know. I don't know what that is.
All right.
I didn't take it, and I would probably fail it if I did.
I'll bet you wouldn't. But, I mean, if it's out of your range of area, why would you? So, okay. So, I think I know more about fluid dynamics and mechanical engineering. Thank you very much for that. Is there anything you would like the layperson, the idiot like myself, to know about what you do that I haven't asked you? Is it fun? Like, do you guys joke around in the office?
Oh, yes. Yes.
Yeah.
Oh, yeah. We do.
You have to wear like a white coat.
This is it. I've degraded. I used to wear. I've never wore a tie in my 30 years.
Right.
But
He's dressed very casually, by the way.
Khakis and nice shirt.
Yeah.
And then over time, it just degraded to what you see today. It's jeans and a Henley.
All right. That's sort of like us in journalism.
And I dress like this because we have to go to the dirty shipyard a lot. You know, like I do crawl around in boxes and
really,
yeah, to look at stuff. You have to.
All right.
Is that bolt screwed in here? And you gotta like,
okay,
get in and look around a corner and get in tight spots. So.
You probably can't say any more than that. That's cool.
No.
I like it. I like that you are hands-on at Electric Boat.
I like all the people I work with.
Good.
And it changes frequently, but I think I'm halfway respected.
All right. Thank you very much, Jaime Duquette, for being here with us today.
Thank you for having me, Rick. This is fun.
All right.
And if you get questions and I need to come back,
we can do that.
Let's see how this goes.
All right. Job Description is a production of the Day Publishing Company in New London, Connecticut, and is hosted by me, Rick Coster. Peter Wappy produces and edits the show. Our theme song is Here and Now by the band Wind Up, written by Michael Clay and Ernie Myers. Can't get enough of me? I write a free weekly newsletter called The Fun Never Stops. You can subscribe at theday.com/newsletters. If you want to support this podcast, leave a rating or a review wherever you listen to, or even better, subscribe to The Day at theday.com/subscribe.